Hi and welcome to video 2 for section 3.7. This is the second of 5 videos. I want to just do a little cleanup from the end of video 1. So I forgot in that example we were supposed to state the domain and range. So I quickly drew this picture back. So our domain is what? The domain is everything except for x equals 0. So the domain would have been negative infinity up to 0, can't include it, 0, up to positive infinity. And how about the range? The range was everything from negative infinity up to positive infinity without including 0, so the range, it looks the same. Negative infinity up to 0, union 0 up to infinity. So again, I just wanted to finish that up. Forgot to do that in the end of the last problem for video 1. So that would be our domain and range in interval notation. Okay, so on to some new stuff for video 2. And in video 2, we're looking at transformations of graphs of a rational function. So before, when we had our base graphs, x squared, x to the third, square root of x, absolute value of x, we were able to just take the base function. So if it was x squared, take a parabola, shift it left or right, reflect it, move it up or down. The same holds true for rational functions. So let's say I want to graph and state the domain and range. I'll try to remember this time. For the following, r of x, so our rational function, is 2 over x minus 3. So remember what we did when we had our transformations. We wanted to get our base function, and then depending if there was stuff inside or outside or multiples of it. So I'm going to rewrite this instead as 2 times 1 over x minus 3. The reason I do this is what? Well, that 2 now becomes a multiplier. So what does it do? It doubles it, right? But, just as before with my transformations, I start with my base function, which is what? 1 over x. So I know that that would have been this guy here. So if I was just graphing 1 over x, which you remember from video 1, that's the picture that we have. But now I have a minus 3 within the function. And when I have a multiple or a value inside the function, that's what? That's our IHOP. That's inside is our horizontal shift, the opposite of what I see. So what I see here is minus 3. So that means what? It's a horizontal shift of plus 3. So instead of these asymptotes being on 0 and 0, the whole thing slides over to the right, plus 3. And now I get, maybe I should do this in a different color. So I knew what the 1 over x graph looks like. It's sort of the L and the upside down L. But now it shifted it right 3 units. So my asymptotes, instead of the sort of intersection occurring at the origin, it occurs over here at 3, 0. And again, the 2 in front is just my shrinking or stretching. So it just makes it look taller, which again, if we're just sketching this, it still has essentially the same shape. And that's it. So it was our base function 1 over x. We slid it to the right by 3 because it was the inside, so that's our horizontal shift. And the 2 stretches it, so it shifted it over. So now, that's the graph. How about my domain and range? Well, the domain is everything except for x equals 3. So that's negative infinity up to 3, union 3 up to infinity. And how about the range? Well, we didn't have any vertical shift, so the horizontal asymptote is still at 0. So it's just negative infinity to 0, union 0 to positive infinity. So that's a transformation of one of our rational functions. Let's look at another example. So if you need to follow up, go ahead and hit pause and follow through if need be. Otherwise, I'm going to erase all this. Do that. All right, so again, let's graph and state the domain and range. This time, my r of x is equal to 3x plus 5 over x plus 2. So, I want to get this in a form where the denominator looks like a rational function, nothing in the numerator. So what I need to do first is, what do I really have here? I have 3x plus 5 divided by x plus 2. So this goes back to our division of polynomials, and I can do synthetic division here because I have the x plus 2. So if I divide that, what do? I take the coefficients, 3 and 5. This is x minus c, so my c would be a negative 2. And I'm just rewriting this. So I'm just dividing it out so that I can get a value and then see if I have any remainder. So for synthetic division, what do? I bring down to 3. 3 times negative 2 is negative 6. I bring that value up. 5 minus 6 is negative 1. So this is my remainder. That's the value that I have. So this thing can really be rewritten as 3 minus the remainder 1 over what I was dividing by, x plus 2. So again, I wanted to rewrite this so that it was of the form where I could actually do a transformation on it. So all I did was my synthetic division on this part to get my value 3 with the remainder that goes over the divisor. So if you're okay with that, now let's graph this. So let's think about what's going on. Well, I have my 1 over x function, my basic rational function. I have a plus 2. So that's doing what? So I have my basic function is 1 over x. The plus 2 is inside of the function. So that means it's a horizontal, the opposite. So I'm going to have to go to the left 2 units. I have a negative in front, so what does that do? That reflects it on the x-axis. And then I have a plus 3. So if the number's outside by itself, that's my vertical shift. So that means I'm going to move up 3 units. So if I was to graph this, what I'm going to worry about, or what I'm going to move around and before I start graphing, is the asymptotes. Because the asymptotes normally line up on the base function on the x and y axis, right? But this whole graph is doing what? It's moving to the left 2, and then it's moving up 3. So instead of the intersections of the asymptotes being at the origin, it's left 2 and up 3. So the asymptotes are actually going to lie at that point there. So I move the asymptotes. I know this is where the graph lines up. Typically it would be what? It would be the upper right and the lower left. But because of this negative sign and this whole graph is reflecting, it's essentially doing what? The top piece is coming down and the bottom piece is coming up. So instead of top right, lower left, I now have upper left and bottom right. So that's the graph I get for this rational function. How about domain and range? Well, domain, all the possible x values, every x value I can use except for negative 2. So the domain is going to be negative infinity to negative 2 to positive infinity, And now the range has changed. So the previous examples, it was everything but 0. But because this thing slid up, I can't use what? Positive 3. So I can have any other y value except positive 3. So that means the range is now negative infinity to positive 3, union positive 3, up to positive infinity. So that's it. That's the end of video 2. That's graphing rational functions using our ideas behind the transformations of graphs that we had used previously. It's just now we need to do it with the base function being the rational function as opposed to one of the other ones. So come on back, we'll look at video 3 for 3.7.